welcome. So we're just going to review left Riemann sum, right Riemann sum, midpoint Riemann sum. So left Riemann sums place the left corner of the rectangles used to estimate the area on the curve. So we start off on the left-hand side. Gee, I wonder what this screen was doing here. Get rid of this screen. I don't know why I have a screen here. Well, look who's here. I haven't seen you in ages. Students, do you remember Melvin? He used to appear in the trig functions videos in Algebra 2. You're moving up in the world. You decided to appear in my calculus video. You were lonely. Yeah, I can understand that. It's pretty lonely here. There are no students. It's just me. You got a cool new hat, though. I like your hat. I like it a whole lot. So you're going to help me, Melvin, on this video? What about your friend Philippe? He's not with you right now? I hope you guys didn't have a falling out. All right, well, here's Melvin with this cool new hat. It even has his name on it. All right, so here we have an example of a left Riemann sum. Left Riemann sums are an underestimation of the area under a curve due to the empty space between the rectangles and the curve. But that's not true all the time. It's true in this case. It's for increasing functions only. Melvin wants to share with you when it would be an overestimate. So for decreasing concave down functions, the left Riemann sum or the left rectangular approximation method, that's just a mouthful. That's why I like Riemann sum. The left Riemann sum overestimates, right? So it depends. Is your function decreasing? Then the left Riemann sum is going to be the left value is going to be the larger value, and the left Riemann sum will overestimate. If it's an increasing function, then it's going to be an underestimate. All right. Let's take a look at the left Riemann sum. Thanks, Melvin. Thanks for helping me out. I hope to see you soon. And as we wait for the page to change. Oh, it's good to see you, Melvin. Oh, you're going to hang with me, Melvin, for a little while until the page changes. There we go. Right Riemann sums place the corner of the rectangles on the curve. I wonder what can be hiding under this screen. Let's get rid of the screen and see who's there. It's Felipe. Oh, what are you doing, Felipe? I was wondering about you because I saw Melvin on the last page. Felipe is Melvin's buddy. He was also in the trig ratios functions. Well, you have a cool new hat too. You're going for the Western look, huh? Oh, well, you're in Arizona, so that makes sense. You both got your names on your hat. I like that. I like that a whole lot. Got a cool hat. So you're going to help me with this video, I see. All right, so Melvin helped me in the last one. Felipe is going to help me on this one. Right Riemann sums are an overestimation of area because of all the extra space that's not under the curve that's still calculated in the area because it's inside the rectangle. So we can see, look at all that extra that's not under the curve that's a part of the rectangles there. So we're overestimating here, but it's not true all the time, right? A right Riemann sum is going to overestimate for an increasing function or one that is concave up, which is going to be an increasing function. Felipe here wants to tell us when it's going to underestimate. So for decreasing concave down functions, the right Riemann sum underestimates, right? Because the value on the right is smaller than the value on the left. Well, thank you so much, Philippe, for joining us. Oh, it's good to see you guys. I've missed you. And I'm just waiting for the page to turn. Look who, they're both here. Oh, look at that. I knew you guys couldn't stay away from each other for too long. So midpoint Riemann sums place the middle of the rectangle on the curve. So the midpoint Riemann sums are the most accurate because the area found in the part of the rectangles that is over the curve makes up for the area lost in the space between the curve and the rectangle. Well said, Melvin and Felipe. Well said. And you can see right here is where the values are. Right? So it is the middle values that we are using. So before I go to the next problem and leave this page, I see you both have your names on your hats. Is it just a thing now? You want to wear your names? What's that? People were confusing you. I don't see it. Do you see it, student? I don't think you guys look all that much alike. They're getting you confused. Well, now nobody will mix you up because you have those cool new hats. Well, thank you so much for your help on this video. I don't know if I could have done it without you. And will I see you again on another video maybe? You think you're going to show up in geometry. They don't know who you are yet. You're going to have to introduce yourselves, all right? All right, well, bye for now. We're going to do some midpoint Riemann sums, and maybe, who knows, maybe we'll see you in another video this year. All right, bye, guys. Wasn't that fun seeing Melvin and Felipe? All right, so we're going to do a couple, if it ever changes, maybe we'll just keep on seeing Melvin and Felipe. We're going to do a couple, there we go, Riemann sums. Now, there's nobody hiding under this one. I put this up because I did have it written up. This is actually a pretty easy one. We haven't done any linear functions. So I did a linear function. Calculation is really easy, just moving this. The screen seems to be difficult. All right, so we want to find the area between y equals 3x plus 2 and the x-axis. Actually, all of these Riemann sums are going to be between the curve and the x-axis. Surprise, surprise. Because that's where our curve is going to end. It's just for the positive values. So change in x, we're just going to take the difference in the values, 3 minus 1, divided by how many partitions? We want 4, so it's 1/2. So when we're calculating it, it's going to be the halfway points, right? So it's going to be 1/4 the distance, because the whole bar is a half, right? And so 1/half of a half is going to be 1/4, right? So add 1/4 to the left side of the bar, and that's going to give you the midpoint. All right, so halfway between 1 and 3/2 is 5/4. It's going to squeeze in there. Halfway between, because 1 is 4/4 and 3/2 is 6/4, so halfway is 5/4. And then what I do is I find the first one, and then I just count up by the change in x, and I don't have to keep figuring out what's halfway between 3/2 and 2, and 2 and 5/2, and 5/2 and 3. So we're going to go up by half each time because the width of the bar is a half. So the mid value is going to be 7/4 for the bar, but that goes between 3/2 and 2. 9/4 is the midpoint value between 2 and 5/2, and 11/4 is between 5/2 and 3. All right, and we plug those into our function. It's a pretty easy function. We're multiplying by 3 and adding 2. All right, so f of 5/4 would be 3 times 5/4. That's going to be 15/4. 2 is 8/4, so that's 23/4. F of 7/4, that would be 3 times 7/4 is 21/4, plus 8/4 is going to be 29/4. F of 9/4, I didn't even bother to write the function anymore. So 3 times 9/4 would be 27/4, plus 8/4 is going to be 35/4. 3 times 11/4 would be 33/4, plus 8/4 would be 41/4. And then we add up all of those values, so we add up f of 5/4 plus f of 7/4 plus f of 9/4 plus f of 11/4. We add those up and multiply by a half. So that gives us 1/2 times 128/4, which is 128/8, or 16. 16 is the area. What a nice, pretty number. Area under that. And actually, we'll learn another way to calculate out the area in a later lesson, and we'll see how accurate that approximation was. So this one I had all written up for you. The next one I didn't, right? Or I don't. It's in the present. I don't. And this one I'm going to do with you. This one I believe is y equals x squared plus 2. Whenever it decides. There we go. So compute a Riemann sum of f of x equals x squared plus 2 on the interval 1, 3, using 4 rectangles, midpoint evaluation. So it's midpoint Riemann sum. All right, so this will look like, so it's just a parabola shifted up 2. Since I don't need the negative values, I'll start it at 0 just because it makes it easier for me to draw. But I don't need the negative values, so of course I'm not going to put them in. And I don't care how good it is to scale, how well drawn it is to scale. I just need a place to mark the rectangles. So we're starting at 1. I'll put the 1 in there, but I'm not going to write anything else because I learned my lesson until I find the change in x, because then I always have to end up erasing it and fixing it so I have more space. So it's 3 minus 1 divided by 4, 2/4 or 1/2. So the widths of these are going to be a half. So I'm going to count by a half here, and then we'll find our midpoint values. So 1, 1/2, 2, not 1/2, 3/2. Halfway between 1 and 2 is 3/2. 3/2, 2, 5/2, and 3. All right, there we go. So we don't use 1, we don't use 3/2, we use halfway between, and it's not 3/4. We'll never make that mistake again. It is 5/4. 1 1/4. All right, so that's going to go right there. And that's where we measure our bar to. So the bars, they're going to be the same. The bar is the same width. It's exact same bar in terms of width, whether I use a left Riemann sum, a right Riemann sum, or a midpoint. It's just what value am I plugging in? Am I to find the height of that rectangle, so then I can find the area by multiplying by the change in x. So if it's a left Riemann sum, we would use 1. If it's a right Riemann sum, we'd use 3/2, and if it's a midpoint, we use 5/4. That's the only difference, right? What value we use. So we're not going to use 3/2, we're not going to use 2, we're going to use halfway in between, which is 7/4, because I've now done this particular size rectangle enough to know it's going to be 7/4. Halfway, we're not going to use 2, not going to use 5/2, we're going to use 9/4. Okay, and there's our rectangle, sort of. And then we don't use 5/2, we don't use 3, we use the halfway point, which is 11/4. Right, so the width of the rectangle doesn't change, the height changes based on which of the 3 values we're using, the left-hand side, the right-hand side, or the value in the middle. So now we're going to add those up. So our change in x, our sum is going to be the change in x, which is 1/2. And then we're going to plug in and find f of 5/4 and f of 7/4 and f of 9/4 and f of 11/4. Well, I just put that in there. All right, so should have wrote a little smaller. F of 5/4, that would be 5/4 squared plus 2. All right, so that's 25/16 plus 32/16. I hate trying to add everything, keep it in my head. 57/16. On the right side, we do have a common denominator. So that's going to be 7/4 squared plus 2. So that's going to be 49 plus 32 is 81. And then 9/4, that's 9/4 squared plus 2. So that's a 4. 81 plus 32 is going to be 113/16. And then f of 11/4 is 11/4 squared plus 2. That's going to be 121 plus 32 is going to be 153/16. All right, so our sum of the areas of the rectangles is 1/2 plus 57/16 plus 81/16 plus 113/16 plus 153/16. We'll add those up. So 113 plus 81 plus 57. These aren't that many bars. 404. Definitely both divisible by 4. So that would be, I'll just put it here. 1/2 times 101/4. So I just divided 404 and 16 by 4. So that's going to be 1018. And there we go. we're done. All right, so this one wasn't so bad. It's not so bad if you have 4. When you have like 10 rectangles, that kind of takes more time. Yours and your homework, you have a variety. I think this is it. I think the next one is some real world problems, and that is going on a whole other Nearpod. I'm pretty sure of it. So before we head out, so real world problems with tables. Ooh, exciting, exciting, exciting. Who knows? We may see Melvin and Felipe again. They may get too excited about those tables. But before we go, let's say goodbye to our guest hosts here, helping us learn some material. Go back one more slide. And here they are, Melvin and Felipe. As soon as the page changes, if I just hold this out a little bit, there we go. So thank you, Melvin and Felipe. I hope you enjoyed this lesson. And who knows, where I'll see you again. Oh, thanks so much. They said they enjoyed it too. I hope you heard them there. They're kind of quiet, guys. So everyone say goodbye to Melvin and Felipe. And that's it for me. Bye for now.